Hello guys, so we are going to continue discussion with respect to linear transformation. So till now guys, we saw multiple examples with respect to linear transformation. But the question still comes in minds and probably in everybody's minds. Why do we really require linear transformation? So once you probably cover this entire mathematics part, right, from wherever you study machine learning, deep learning, probably in every, at least from my side, if you check out just my Udemy courses on machine learning, deep learning, and natural language processing, there in every algorithm, every machine learning algorithm, there is extensive use of linear transformation techniques. It can be used to solve a regression problem statement, classification problem statement, even in unsupervised machine learning like dimensionality reduction and all, right? So here I have noted down some 10 important properties and why 10 important applications of linear transformation, which will go one by one. Okay. And again, understand that if you really want to understand this much more better, right? Probably if you just keep some things in mind with respect to this mathematical equation, and let's say from wherever you are learning machine learning algorithms or deep learning algorithms, you as soon as you probably read each and every algorithm, if you understand the mathematical intuition, there some or the other way linear transformation will be specifically used. So here you can actually see, so let's go ahead and talk about point by point. Here are some of the reasons why linear transformation are important in data science. So first of all, the technique is specifically called as dimensionality reduction. Dimensionality reduction is where, let's say in my data set, I have many dimensions, many features, like 5,000 features, let's consider, right? Now this particular features, obviously we will not be able to visualize it, right? And as a human being, like max to max 3D, we will be able to visualize 3 dimensions, right? But what happens if you have 5,000 features, if you have 100 features, if you have 500 features? So dimensionality reduction is a technique wherein we convert this higher dimension to lower dimension, so that we will be able to make sense of the data, how the data is basically, we'll be able to visualize them. If I really want to visualize them, I'll just convert this 5,000 into 3 dimension or 2 dimension, right? But here the main idea is basically to convert a higher dimension into a lower dimension. And while we are converting this, we also need to make sure that we capture a lot of variance within the data, right? Variance are information that should not be lost. Variance basically talks about how your data is basically spread. And as we go ahead in statistics, we'll also be learning about this. Anyhow, in this particular course, what I have done is that the machine learning algorithms like principal component analysis will also be added. So there, the mathematical intuition, once you see over there, also we basically use linear transformation. So here it basically involves finding a set of orthogonal axes, which is also called as principal components, and projecting the data on those axes. Okay, this is the main step that we specifically do, and for this we really need to do the transformation of the data points. Okay, so for right now, just remember this particular points, but once you probably see principal component analysis, which is a kind of dimensionality reduction technique, there will be an understanding that we will be performing this kind of transformation. Transformation basically means I will take a vector, I will be having some vectors, we will change it to some other vectors, right? Making sure that the two properties are basically captured. Then linear transformation is also used in feature engineering, right? Let's say you want to go ahead and create a new feature from the existing one. So you can specifically use some kind of transformation technique. Interaction between two features can be captured through a linear combination. Let's say there's a concept of something called as covariance and correlation, which we will be learning in statistics. There also transformation techniques are specifically applied, right? Techniques like linear regression, ridge regression, these are some of the machine learning algorithms where again linear transformation will be applied. Okay. Coming to the next step, that is called as data pre-processing. So one of the most fundamental step that we specifically do in feature engineering, which is called as normalization and standardization. Normalization or standardization, let's say that I perform a normalization wherein we scale the data to a specific range. This is 0,1 value. So it cannot be directly scaled, right? If I have some values, I need to probably do the transformation, then only it will be able to scale between 0 to 1. Normalization also can perform where your mean value is 0 and standard deviation is equal to 1, right? These all things we will still be learning in statistics, right? So just remember right now, normalization and standardization are one of the very important concepts where transformation will be used, right? Because at the end of the day, we are changing vectors over here. Then you have neural networks. In neural networks, if I probably consider, or if you are going to learn in the future, from anywhere, right? You'll be also seeing that there is a concepts like forward propagation, backward propagation, activation function, right? Here in all this kind of scenarios, linear transformation is specifically used. Then you have image and signal processing. Specifically in deep learning, you have a concept like CNN. There we use convolution filters. Here also linear transformation will be used. So just to make sure that you have some of the idea beforehand, right, I've written all this description so that you will be able to just read it and find it out where all things specifically linear transformation is basically applied. Again, I if you are starting it for the first time, I'm sure like you'll not be 100% sure where linear transformation is used, but once you start learning machine learning algorithms and deep learning algorithms, once you perform EDA feature engineering, you'll be able to understand how linear transformation is applied. But at the end of the day, you are converting one vector V to W, let's say, by applying some kind of transformation. And this transformation basically satisfies two rules. One is additivity and the homogeneity, right? So yes, this was about linear transformation. In the next video, we are also going to see about some visualization to just understand that how does linear transformation looks like. And that visualization will be helpful for you. So yes, this was it from my side. I will see you in the next video. Thank you.